So having looked at the product rule, which is when we take two functions and multiply them together, we're going to now look at the quotient rule, which is obviously when we divide two functions by one another. Okay, so it's a different rule entirely, and again, we could have looked at it in higher, but obviously it's a little bit more difficult, so we've saved it for advanced higher. Okay, so this is now a third thing to look out for when you're asked to differentiate, because to make it clear, and I already have kind of touched on it a couple of times, in an exam you're just going to be asked to differentiate. You need to spot, is it the chain rule that's required, is it the product rule that's required, is it the quotient rule that's required, or is it a combination of all of them? Okay, you can prove this. I'm not going to prove this just now. You can have a look for yourself if you want to, but it's kind of proved through a combination of the product rule, obviously, and a little bit of indices. But yeah, I'm just going to kind of show you the rule. And in a similar way, if you use other textbooks, other kind of documentation to look for this rule, it might be given in a different form. I'm going to use a form that revolves around the f and the g, similar to how I did the product rule. Okay. So basically, in a situation where you have a function f of x divided by another function g of x, and we want to find the overall derivative of that whole function dy by dx, then it goes something like this. Okay. So that looks a little bit confusing, but if you actually look closely, it's very similar to what we did in the product rule, certainly the top stage. And because of that, it can be easier, but because of that, it can also be kind of cause a few problems. So it's virtually the same as what we did in the product rule. So f dash g and then g dash f, but it's take away this time. Okay, so the product rule is f dash g plus g dash f, but this is f dash g minus f g dash, or whichever way you want to call it, and then it's divided by, and this is important, the first function, this kind of the denominator function, the function that we're dividing by squared. So it's not differentiated, it's just that original function and it's squared. Okay, so kind of a simpler way of writing that, f dash g minus g dash f divided by g squared. Okay, so again, it's another rule that we need to learn. It's quite a complicated one, so if you try and do this a different way, if you try and just differentiate the two functions, it won't work. This is how we have to differentiate when we've got a function divided by a different function. Okay. Cool. So I'll show you some examples. So the first one again, so I'm just going through the different ways it can be written. We're trying to find d by dx, so we're trying to find the derivative of this function. It's not dy by dx because there's no y given for the function. So just look out for the different ways that can be written. But this is x cubed divided by sine x. We're going to try and differentiate the whole thing. Right, I would set this up in the same way that I did the previous one. Okay, so you're going to split up into an f of x and a g of x. So you have to get these around the right way. Obviously, you've seen the formula. The fact that there's a negative, the fact that there's a divide means on two counts we need to get the g of x right. So the g of x is the bottom one. So the f of x has to be x cubed. The g of x is going to have to be sine x. So differentiate each one individually. So f dash x is 3x squared. G dash x is cos x. Okay. And then it's just a case of putting it into the formula. Okay, so I suggest you keep writing this down. It's not going to be given in your formula sheet, so you're going to need to get used to this formula. So write it down and then put everything in. Similar kind of idea, it's f dash g, so it's these two multiplied together, so 3x squared sine x. Take away these two multiplied together, cos x times by x cubed, divided by this one, so not the derivative, but this one squared. Okay, and obviously we can write that as sine squared x. Right, a couple little pointers because I've noticed from the work that you've done so far a few mistakes in terms of the way that you're writing these things. So these two especially here. So when we're given a combination of an x function and a sine or trigonometric function, so most of you I think are getting that idea that you'd write the kind of the non-trigonometric function first, just so you don't get confused. The problem is, especially with this one, if you wrote cos x, x cubed, it almost actually implies that you are finding the cos of the x and the x cubed. Okay, so it's better off writing this first. So similar in a way to how we write a number first. So you never write x3, you'd always write 3x. You want to write basically the trigonometric one for second, just so it just is a little bit more clear. Okay. Right. I've written that one out in full. You could technically take out x squared as a common factor on the top. It really doesn't make a massive amount of difference, but just be careful if you're looking at answers, it might be done like that. The point in most of these questions is that what's going to happen, there's probably going to be a part B question where you might have to use this. So obviously you've got lots of different applications for differentiation. So it might be a part A, and then part B might be a hence. Find the gradient of the tangent. at point such and such on this curve. Okay, so in a similar way to how you did higher in terms of you had a derivative and you had to apply it to something, you might have that here. So what I'm basically saying is, in terms of the simplification, you're really simplifying for yourself. If you have to use this in a second part, if it's simpler, if there's a common factor taken out, or if you've taken, so a couple of you missed the sine x over cos x in the previous example, that simplifies to tan x. It's just going to make your life easier for the next part. Okay, so try and simplify if you can. It's not necessarily you don't have to do it, but it's probably going to make your life a little bit easier. Okay, so second example. So again, we're finding the derivative, but this time it's x to the power 4 over x plus 1. So again, just split it up into your f of x and your g of x, differentiate each one, and then substitute them into the formula. Okay, f dash g minus g dash f over g squared. As I say, keep writing it down just so you get used to it and you memorize it. Okay, but shoving everything in, just be careful with your brackets here. 4x cubed times by x plus 1 in brackets, and then minus the x to the power 4 times by 1, and then all over x plus 1 squared. Okay, you can multiply that out. I don't think I've done it here. No, I haven't. Okay, you can multiply that out and maybe make it slightly simpler, but for the time being, as I say, we're just kind of really getting used to the formula, so that's fine as it is. Okay, so find dy by dx, we've got a function y equals, but it's still a quotient, it's sine 2x divided by e to 3x, but we're bringing in a couple of different aspects here. So the first two, we're just to get used to the quotient rule, sorry, but we're going to bring in a bit of an exponential. There's actually also a bit of chain rule here. So again, you have to think about all these different aspects. Okay, so some of you I can see already are getting used to the fact that sine 2x is very, very easily differentiated. You don't have to use the chain rule for it. Okay. I'm going to split it up here though to show you exactly what I mean. But start in the same way. You've got f of x is sine 2x, you've got g of x equals e to the 3x, and then you want to differentiate each part. As I say, the point of both of these actually, I don't think I've actually done it for the e to the 3x because you've actually got this kind of differentiation in the table here. This is still chain rule as well actually. Okay, so we've got y equals sine u equals 2x, blah, 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 blah. The derivative is 2 cos 2x. Okay, I know most of you can do that. It's just basically multiplying by the derivative of this bit as well as the derivative of the whole thing. So it's 2 cos 2x. And the derivative over here, same idea, multiplying by the 3e to the 3x. Okay, so then just put it in the formula. Okay, and you've got a common factor there, but again, you don't have to take it out. But the point of this one is that you can simplify. If you've got e to the 3x and e to the 6x on the bottom, then they can cancel out. And you can write it like that, e to the minus 3x, by moving everything to the top, or you can write it all over e to the 3x. Okay, it really doesn't matter. Okay, but that's the quotient rule. As I say, it's just getting used to it just now, but bear in mind the overall idea of this is that in an exam we're going to be asked to differentiate, so we need to be accustomed to all the different parts of differentiation. Okay.